Hi, in this video we're going to solve some problems involving the conservation of mechanical energy. So in this first problem we have a boy who drops a rock off the edge of a cliff. A lot of cliffs in physics, I don't know why that is. Originally the rock had no kinetic energy and 600 joules of gravitational potential energy. After the rock has fallen to a height that is 1/3 of its original height, what is the potential energy? Assuming no air resistance, what is the kinetic energy? So we're going to assume that there's no external forces acting on this rock as it falls. We're going to keep things simple. So this is the cliff. This is the boy dropping the rock. Let's use a red rock. Okay, and so he drops it. It's falling, 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 falling. And it says it falls to 1/3 of its original height. So maybe somewhere like right around here. So we want to know what is the kinetic energy and potential energy of the rock at this point. Okay. So to find out, we have to first, do some, we need to write down what we know about the kinetic and potential energy at the beginning. So we were given that the kinetic energy initially is 0. So I've written KEI for initial kinetic energy, and the potential energy at the beginning, the initial gravitational potential energy is 600 joules. Okay, and we know that wherever this rock is throughout its fall, it's going to maintain a constant mechanical energy. So if we added these two together to give us our mechanical energy, that would be the total mechanical energy is 0 plus 600, which would be 600 joules. So at every point in this rock's descent, doesn't matter where we choose, it could be anywhere, it will always have 600 joules of total mechanical energy. Now, obviously, it's changing its gravitational potential energy into kinetic energy as it falls. So by the time it gets to the bottom, right before hitting the ground, it's still, got 600 joules of mechanical energy, but all of its potential energy is turned into kinetic energy at that point. So these are all the total mechanical energies as it falls. And that's important because we'll need to know that to find the answer to this question of what is the potential and kinetic energy as it falls down. Now, to find the potential energy, it should just be 1/3 of the original potential energy. So the original potential energy was 600. And if it falls to a height that's 1/3 as much, then the new potential energy is just going to be 1/3 times the original. And that's because potential energy has a directly proportional relationship with the height of the object. So if it's 1/3 as high, it's going to have 1/3 as much potential energy. So 1/3 times 600 is going to give us a new potential energy of 200 joules. Okay, so that means right here we can write the potential energy equals 200 joules. And if that's true, then in order for the total mechanical energy to still be 600 joules, that means the kinetic energy must be 400. So that if you added those two together, 200 plus 400, you would get 600 joules of total mechanical energy throughout the descent of the rock. So that's all I've got for you in this video. Remember, habit is the battleground of character.